So I'm going to give a brief explanation of CMake Tools, which is a VS Code extension to help you debug C++ applications. And then I'm going to study the source code more. I'm trying to figure out, try to understand. So I'm trying to debug a C++ application, and if I debug with a launch.json file, it doesn't work. But if I debug through the extension CMake Tools, then it works, and I want to understand why. So that's what I'm trying to do. But I'm gonna give a brief explanation of the stuff that I understand so far. And I don't, I think it's very confusing the way that they did the documentation. Maybe it's obvious to other people, but for me, the structure of the thing makes it very confusing. But as far as I understand now, the way that it works, I think this is a good article, is from the extensions documentation from VS Code. So the way that it works is you set up a launch.json file on the .vscode folder, and you cannot. I think the tasks.json is optional, and if you do build or if you do create a tasks.json file as well, then you have to put here on the pre-launch task on the launch.json, and the launch.json is going to have the specifications of how the debugging process is going to work on VS Code. So as far as I understand, the task.json is whatever happens before the debugger starts, and the launch.json is whatever happens when you're going to debug the thing. So here is the specifications for what you want to happen when the program you want to debug is going to run. So here, and this is the part that is kind of confusing, because based on the documentation and the way that they do things, I think it's on the CMake, the build with CMake here, the link, it goes directly to the documentation from the extension, and that's not very clear. But this is the source code for the CMake Tools, which is a VS Code extension, this one. And I have the source code here, and I'm going to explain a little bit the source code, the part that I studied so far. But this documentation is related to the extension itself. So the only reason why, on the documentation, they put this code here, which is an example of how to debug using CMake. So like the challenge is that on C++ projects, you're going to have a bunch of different files that are going to become object files, which are each C++ file on the whole project is going to become an object file, because there are several steps to the compilation process. Then after they become an object file, you're going to use a linker to connect the declarations with the definitions. And then after you do that, it creates the executable. And then the executable has information for debugging. But there's another thing that I'm kind of confused about, which is that the way that I'm building now, like depending on which kind of flag you pass to the compiler when you are going through this process of building the object files and the linker, you're going to create different types of executable. So you have the debugger version, the debug version, and the release version. And the debug is less optimized. So you pass a flag to the compiler. And then based on that flag, is going to determine whether it's going to build the debug version or the release version. The debug version is less optimized, but it has symbols. And then because it has symbols, it allows you to use debugger, which is normally people are going to use the GDB, which is another C++ project that they created to just step over the code and figure out what's wrong. So because when you build the debugger versions, because you have symbols, it allows you to create breakpoints on the project. But the downside is that it makes the executable slower. So because of that, there's these different kinds of ways you can build the project. And so all this complexity makes it harder for you to step over the executable from C++, because you have all these files. So if you want to debug a simple project, then it becomes very easy to do the configuration, because all you have to do is pass the path to the executable we have, and then VS Code is going to figure out like how to initialize GDB and pass the executable that you want to debug to the debugger. But if you want to debug a more complex project, then it becomes a problem because then you're gonna have to set up the configuration in a way that allows your VS Code to know all the files, all the C++ files that you want to become an object and all of that. And because of that, people use CMake to build C++ files, to build the executable, because CMake allows you to create this file, which is CMake list, which has another, it's another language they created, is a scripting language, and then through these specifications, it allows you to build the project. So what CMake does is to build a makefile, or you pass whatever generator you want to use, which there are several different generators because there are several different compilers for C++. Then based on the generator you selected on CMake, it's going to build a bunch of files, and then you pass the folder to whatever folder you want to put these files on. Which in my case is usually the build folder. So you run a command, it puts all these files on the build folder, which is everything that the compiler is going to need to build the project. And then you run another CMake command. This part is kind of confusing to me, and it's something that I'm trying to clarify. But as far as I understand now, the second time you put the CMake command, in my case, I'm using this command here, the build. Then it's gonna call the compiler, whatever compiler you use on the generator process, which in my case is the MSBC compiler, which is the Visual Studio compiler. And then based on, because I selected that, it created all these files for the compiler to be able to compile the project and create the final executable. So this other command here is gonna create the final executable. And if you put debug, then it's going to put on the debug folder. If you put the release, if you create the release flag here, it's going to put on this folder here. And then it creates this file, which is the CMake cache, which is going to cache all the options you passed on the configuration process. So you don't have to pass each time. You want to rebuild. Let's say you change the project and then you run this program again, then the compiler is going to compile the project again. So the way that it works, so for that reason, because you use CMake, in my mind at least, it makes it a lot easier if it's possible to tell VS Code to use CMake to build the project and then to attach GDB to the final executable after you build with CMake. So the way that I'm thinking about it now is, and the way that it makes the most sense in my brain is, you put whatever command you want to put on the tasks.json to build the project using CMake. And then after that, you just put the specification of where the final executable is going to be, which is going to be this program path here. You put the path of the executable. Here, these flags are not necessary because I was confusing the steps. But this configuration here is pretty much saying, run the executable, the final executable. You pass the path here, which is going to be this debug path here, to the final executable. And then you specify which kind of debugger you want to use, which in my case is GDB. And then you pass the path to GDB on your system on this thing here. And then the part that gets very confusing is understanding what VS Code is doing under the hood to make this happen. So here, based on the documentation, they tell you that if you want to put additional symbols for the compiler to know how to put breakpoints, then you can put these keys here, and then you can pass the path to the symbol files, which are these .pdb files here. But the thing that is not clear to me is, because when I run with GDB here to the command line, it tells me that the final executable doesn't have symbols. But based on the way that I set up the CMake list file here, you can put this this flag variable here, and whatever you put after this and this environment variable is CMake is gonna attach that flag when it's compiling the project. So this is the same as compiling the file by passing these flags here. And the G flag, when you're using the GCC, is going to be the flag that allows you to create a debug version of the executable, so load the symbols. And when you're using Visual Studio, the flag is going to be this one. So based on these commands here, the CMake should be creating a final executable that has the symbols on the executable itself, so you're able to run with the GDB and create breakpoints. But the issue is that when I run with GDB, the final executable here, it tells me that the file doesn't have symbols. It couldn't load symbols for the the final executable. So I'm not really sure what's up with that. And I spent a bunch of time reading the GDB documentation as well. And it seems like you can use some command after you initialize GDB, you can use some command to tell GDB where the .pdb files are. And as far as I understand, the .pdb files are the files that contain the symbols. So I think that it would work if I specify the symbols to the GDB after initializing GDB, and then I would be able to create breakpoints to the final executable. But the issue is that because of the nature of the whole thing, VS Code is going to be the thing that is running CMake. So the thing that I have to figure out is how to set the flags through CMake so that GDB knows how to find the symbols and create the breakpoints. But based on the way that I'm doing here, for some reason, that's not happening. And I think it's because of the biggest issue and the thing that is hard to figure out is how the launch.json is connected under the hood with the GDB and with GDB, CMake, and the final executable. So that's the whole challenge, and that's the whole point of confusion that I have. And this is the problem that I have with the documentation, because in the documentation they don't talk about this kind of things very well. And also this thing that is kind of confusing because it goes from this documentation here directly to this. So it's kind of deceiving because it makes it feel that this documentation is related to the main VS Code itself, but it's not. This is documentation from the CMake extension. And I'm going to explain the source code for the extension because here, so the configuration you build with launch.json is going to be the one that shows up here. So the name you put here, and this is the configuration you're using. So if you put other configurations, they're going to show up here as well. So when you select the target you want to debug, and then you just run this, and then this is going to run the launch.json configuration you have there. And then what this code is going to do is it creates a debug adapter. So the whole logic behind the way that they did this, the debugger framework, is the same pattern you have on web applications, which is the model view controller pattern. So on the front end here, where you have the tools, it's going to be a generic debugger. And then based on the stuff that these buttons here you click, what's going to happen under the hood is that VS Code is going to send an event. And then based on whatever debug adapter you have, you're going to have the logic that sends that event to the debugger, which in this case is GDB. So on one side, you have VS Code UI. Then on the back end, you have whatever debugger executable you're using, which in case of C++ is GDB. And then in the middle, you have the controller, which is the debug adapter, which takes the event from VS Code, and then based on that event, encodes the logic of how GDB is what GDB is gonna do whenever the button is clicked. So, for example, when you have the step over, probably what's gonna happen under the hood is that it's gonna it initialize GDB, and then it's gonna put on the GDB the label to go to. So whatever logic GDB needs to run. But here you can see that the thing that is weird to me is that I'm putting the breakpoints here, but when I put on when I try to debug using this configuration, it just executes everything and doesn't go through the breakpoints. And it's supposed to go through based on the launch.json configuration. So what I assume is wrong is probably the debug adapter. And that's kind of the problem that I have because I don't understand very well at what point is VS Code gonna place the debug adapter under the hood based on the launch.json configuration, and how does that logic work? So as far as I understand right now, the way that they recommend you to do is to use the CMake Tools extension, and then the point of the CMake Tools extension is that they are going to create all the logic to create the debug adapter. And for that reason, when you click this button here, comes from the CMake Tools extension, which is this extension here, which I think I already showed. So when I click this button here, what's going to do is going to go through a similar process, but it has a bunch of code on the source code there that is going to build the project based on this command here, which is similar to the way you would do it manually. So It builds the project, and then after it does that, it creates, it's gonna call some VS Code extension API function to start the debug adapter, but based on the configuration that they create with the code from the extension. And when I try to do it with this route, then it works. It puts the breakpoint here. So the whole question that I have is why, when I use the extension directly, the breakpoints work, and why, when I try to do it through the launch.json, it doesn't work. And I assume that the only reason is probably because of the symbols, the way that they are loading the symbols, but it's kind of confusing to me. So that's the thing that I'm trying to clarify. So I think that the image here shows really well how it works. And then they have this site here, because the debug adapter is something else. It's separate from VS Code. It's just something that they use. So this is the site for the debug adapter protocol. So that's the way that it works here. You have the debugger, then you have the UI from VS Code, and then the debug adapter. So yeah, and now I'm going to explain a little bit of the. So I have this is the source code for the extension. So I'm going to explain a little bit how extensions work on VS Code, and I'm going to explain the functionality of this, what's happening when you click the button there, which is from the extension. So when I click this debug, what's the flow of the logic that is going on? And then I'm going to try to study to see if I can figure out what is the difference between going through the launch.json directly or using the extension to debug the thing. And I think those things are related to the compiler, because, and obviously CMake, because CMake is the thing that is is calling the compiler, and the way that the symbols are loaded, because I think that when you try to debug directly from here using launch.json, if the configuration you're putting doesn't have a way to tell GDB where the symbols are, then the breakpoints fail. I think that's what's happening. So there is one way that I'm thinking about solving this, and that's the reason why I did this tasks.json, but it seems like it's not working. So here I'm just emulating the command that I would run normally there on the command line. So calling the CMake executable, and then passing the flags here, and then this should build the final executable using CMake, which should put on the compiler these flags here, and these flags should create the debug version. And also you have this type here you have to put. And then based on that, it should create a final executable that has symbols. And then based on the launch configuration here, it should call. So this is an environment variable that comes from the CMake Tools extension, but you can use this other path here to find the final executable. So this should run the final executable with GDB on the command line. And I think the reason why it's not running is because when I run directly from here, the same thing happens where it says the final executable does not have symbols. So this stops me from allowing to put breakpoints. So I think that's what's going on. I think under the hood, VS Code is doing the same thing, just calling GDB and then calling GDB for this executable the same way that I did here on the command line. And because the final executable doesn't have any symbols, then the breakpoints are not created. But if you do it from the extension, from CMake Tools, then based on the way that they build the whole compilation process, it creates the final executable with symbols, and then for that reason, I think that it creates the breakpoints. So if I want to go from the extension to being able to do it just from the launch.json configuration, my logic is I have to figure out what is the difference between the two. So how does the CMake Tools builds the configuration, and how I am building the configuration? So I can translate the CMake Tools the way that they do it through my way, using tasks.json and launch.json. But the thing that is kind of I'm unsure as well, is the whole debug adapter thing, because the difference might be that whenever you use CMake Tools, they're using a different debugger adapter than VS Code uses when you use the launch.json directly. So I'm not really sure about that. Hello, sorry for bothering you once, blah, blah, blah. Oh. Yeah, block. So now I'm gonna go over this. So as far as I understand the way that VS Codes, I'm gonna put some music as well. So as far as I understand the way that there is a simple example here, and they recommend you to use a command there to create your first. So you download this stuff, which is just a generator for. It's just gonna generate a template similar to the way you would build web applications using a framework. Just call some command, then it's gonna build the base files and folders you need to have to build extensions. But I start directly from this thing here. And the way that this one is gonna work is, so as far as I understand now, the initial code for the extension is gonna be on the extension.ts file. And then you're gonna have a function called active or activate, something like that. And this is the main function that is gonna activate the extension. And then VS Code provides you with an API. And through that API, you register commands, and the commands are gonna be the interface of the user with your extension. So the initialization process happens on the activate, I think. And here the activate. So this function is the one that initializes everything. And then on this file, they have a extension class, which is the extension manager, which is the main class that they use to put all the logic of what's going to happen throughout the extension. Then they have a bunch of other files that are going to figure out the logic of the paths and how to set up everything, set up the build process and call everything. So the way that it works is, so this is one example of the VS Code is the API that they provide, and then the workspace. So there's the user settings, for example, on VS Code, which is the overall settings that you have across all different projects you're gonna do using VS Code, and then you have the workspace settings, which is each specific project. So you can imagine like each one of these VS Code instances here would be a different workspace because there are different projects. But across all of them, you have the same user settings. So that's how VS Code separates everything. So here is just accessing the namespace from the workspace. And this get configuration gets the CMake configuration for that workspace. So in my case, I don't have the anything. So it's just going to return null, I think. Not 100% sure, but I think that's how it works there. So it's pulling from whatever you have here. So if I had the CMake here, and then I put some configuration here, then it's just gonna get whatever I put here. That function there. So they initialize the class with this create function here, passing the context. And this is the main context from VS Code of your extension. Is a bridge between VS Code and the logic for your extension. So they create the class using this stuff, then they call that init, and the main function I think is the setup, which is gonna call some function from VS Code, which is called register command. And what the register command allows you to do is to put logic on stuff on the UI. So just creating a class there, and it calls this init from the class. And as far as I understand now, the status bar is the name of this, whatever shows up here, and then they have a class where they initialize that is gonna have the logic of the buttons here. Yeah, so I think that the main one is the setup function here, passing the context. This one is gonna have a generic register function. And then they have all these commands here. So they use the CMake keyword to, like make all the function calls unique. So they pass all the functions that they're gonna register on VS Code through the register commenting through here, and then they loop over all these functions here, and so these functions, and then they call this register, which is the generic function there, passing the key, and this is gonna put those functions on this on the context. So the register is going to take the key, which is the name of the function there, which is this one, and then it's going to put on the CMake thing here. So whenever you register a function through using this thing here, then whatever is the name of the thing that it should register is going to call a callback function, which is the second argument that you pass. So in this case, it's going to call this functionality here whenever there's an event that triggers the commands that you sign up using this thing here. So in this case, the name would be the name of the functions there you have, and then it's going to be CMake, and then after the logic there is going to set up event listers or set up commands for all these functions that are going to have their own functionality. So on this registers command here, it registers all these functions as far as I understand now. So the main one that I want to focus on is on this debug target, because I think that's the one that's actually I know that's the one because I did some tasks there. So whenever you click this button here, the launch debugger for a selected target is going to run the function that is this function here from the extension manager, and it runs. And to be honest, I didn't like that much the way that they did this. It's kind of confusing. It has been very frustrating to understand everything, but then I try to remind myself that like I wouldn't be even able to have these problems if some people didn't work on creating all of this stuff. So like I have access to all of this for free. I think it's very normal to be frustrated at everything. It's just the way that human beings work. So, but I think that's a very good thing to do. Whenever you feel this way, it should reframe in your mind, because there's always two sides to the coin. So the only reason why you're able to have the problems you have is because people in the past went through problems that are worse. And that's always the case, because everything can always be worse in the same way that it can always be better. So the only reason why you have the problems you have is because some people went through problems that are worse. So I've tried to use that too. But it is very frustrating, I'm not gonna lie. So as far as I understand, this is the function that they are running there when you call the thing. And this is gonna call this other function, which is from this class here. So this is a class that they initialize that's gonna handle the logic of building the whole pipeline. And the execute command thing there is gonna be the thing that executes the command from VS Code. It's just the bridge between VS Code and the logic here. Or the command is the function there, and this just gets the active project, which is because they, as far as I understand, the way that they designed the extension is so you're able to use it across a bunch of different workspaces. So I think there's a bunch of logic here that's going to handle whenever you have multiple different projects. So this is just getting the current active project, and then it's going to execute the command there, which is the function from the other class, the build target from the other class. And this is a part that's kind of confusing, because that's what I'm going to spend time figuring out now, I think. Is because I want to understand what are the paths, in order to understand how they build the configuration. But I'm going to show the main thing that I think is... So the final function that is running there, so this just figures out what is the current active project, and then it passes the class, the CMake project, which is one class that is initialized on the extension manager class, that is going to handle the logic for that specific project, and then it's going to call this function for that project. I don't remember what the name is very well. But this is the function that is going to run, and this is the function that has the logic. So the main thing is that to understand is that this debug config here is going to be the final configuration that they pass to VS Code to start debugging. And the main thing that starts debugging is this function here. So this is the API, the extension API from VS Code, and then they have this namespace which is called debug. And this is the main function that is going to initialize the debugger. So what's going on is that VS Code, and also before this, The extension also puts like a thing here whenever you initialize VS Code to select a C++ kit. And what a kit is just a collection of the executables you need to go throughout the whole compilation process. Because on C++ you have the linker and you have the compiler. So, and I think you have other tools as well. So the collection of all those tools is called a kit. And whatever kit you're gonna use is gonna change everything. That's another thing that is frustrating about C++. And the reason why is because the different compilers have different optimizations on the code, on C++ code, so you can change a bunch of things depending on what kind of kit you use. And also it changes the flags and everything else. So the first thing that they do here is force you to select a kit, and then there's a bunch of logic on the extension manager that calls other classes to select, and then they're gonna set up they're gonna use a library from Node.js, which is another problem I have, which kind of was annoying. I'm not 100% sure if the logic is related to that library, but I think it is. So there's a library on Node.js that allows you to initialize bash or PowerShell processes, and they use that library to call a bunch of command line arguments or command line instructions. They're gonna call executables that find the paths. They set up default paths of where they're gonna look for the executables for building the whole toolkit. So there is usually default paths that these frameworks are going to put the executables on. So for example, Visual Studio is going to put on users on C, and then users or C or programs, and then Visual Studio, and then there's a default path there where the CMake executable is going to be, for example, or where the Visual Studio compiler is going to be. So they have a bunch of logic that is going to, based on these default paths, is going to search for what if the user has the kit or not, the executables or not. And then they're going to store this information on some other classes in a bunch of different places. Then based on the kit you have, this logic here is going to figure out the configuration for the final build for the compilation process. And it's pretty much, it's very similar to the launch.json configuration. I think it is the launch.json configuration that they built here. And then based on the configuration, they just pass to this function here. So as far as I understand now, it's pretty much the same as using probably what is happening under the hood, even if you don't use an extension, is that VS Code is doing the same thing. You're just searching for the launch configuration on it's searching for a configuration on a bunch of paths. One of these paths is the launch.json, and then if it finds a configuration on launch.json, it's just gonna pass that configuration to this function here. And that's the main function that initializes the debug adapter. But there's something else, because you can programmatically select or programmatically create debug adapters as well, and they do that on the extension manager class. And that's the reason why it shows up here. After you run the extension for the first time, it's going to show up this other configuration here. And that's programmatically created by the CMake Tools extension. So I'm going to show how they do that. They use a VS Code API function to do that. But as far as I understand, that's pretty much the way that it works. And then here they have something called, they have another class called CMake driver. And the CMake driver is the thing that is going to figure out where the CMake executable is at. And I think that happens on whenever they are creating the kit. They find all the executables, and then they build a configuration just based on this function, I think, here. Now this one is going to figure out based on the logic. So here, this is another class that they have that's going to call this, pass this CMake driver. I think the cache path is the path to the CMake executable. So at the first time that you're running this, you're not going to have a driver, but this function here, I think, is going to initialize the driver class. So it gets the CMake executable, then it passes to this start driver, and this is going to start the CMake driver class with that CMake executable. And it finds the CMake executable by the way that I just said. It searches for default paths on your system. And also uses, at some point, this executable here, vs_where, which is an executable from Visual Studio that allows you to find where the where the Visual Studio is in your system. So one annoying thing that I was trying to build this so I can put print console log statements here to figure out what is going on. But I couldn't do that because I ran into another problem, which is this node geep. They use this node geep library as far as I understand now. And I think that the node geep library is the thing that allows you to build all these commands on the bash or PowerShell programmatically. But the problem is, this is a problem that I ran into some time ago. When you use node geep, is that if you're using the system that I'm using there, they don't have the logic to handle that kind of system. It's based on a file there that they have the logic to figure out where Visual Studio is. And because they don't have the logic to handle for my system, then it thinks that the system doesn't have Visual Studio installation, but I do have. So I wasn't sure. Like I think I'm not gonna go through all the work to change the code to figure this out. So if I can't figure out, I'm just gonna continue to do the other stuff because this is already a tangent that I'm taking to solve this. But I'm not really sure if that's the thing that they use there. I'm just gonna continue to go over the flow there. So I think he's on. He's on this. The function that gets the executable. They have some stuff that. I think is this one. Or this one. Here, for example, is this proc library here that they use. So this proc library is executing commands on the shell, the PowerShell. So this is something that is becoming more clear on my mind that I struggled to understand before. But like the command line of the PowerShell is just a program that creates the bridge between the operational system and applications. And the way that the operational system works is by creating processes, and then you have users. So you have a bunch of logic that separates users and sessions. And the reason why is for security. So it's like fragmentalizing everything into different users and sessions, so you can create different barriers of access, so that programs don't hack the system pretty much. And yeah, so whenever you create commands to execute the PowerShell, is just like creating this bridge between the logic of the application and then communicating with the operational system to do whatever you have to do to manipulate different files and create different stuff. So they use this child process here, I think, and this probably creates a process which creates the terminal based on whatever commands they build here. So here they're just passing the path and then version, and then this probably gets the results of whatever command was executed, because you have inputs and outputs. That's how the commands work through the shell. So this stuff here is the stuff that runs in the beginning there of the whenever you're gonna debug. So you can see the output here. I think it's not showing now, but I remember seeing this before. Try again. I'm just gonna. It's weird that it's not showing now. Or maybe it's because I'm putting the tasks.json there. No, that doesn't make sense. I don't understand. I'm gonna try to delete all this stuff. Let's see if it's gonna show or not. I wrote down there on the file the commands that run. And now it's not showing, I don't know why. But these are, based on previous times that I run this, those are that's the sequence of commands that runs whenever you click the button there to debug. So it did run these commands here. It shows there on the output. I don't know why it's not showing now. Maybe it's because of the kit, but I'm not really sure. So the way that it's building these commands is through here. You can see that it's building here. And this is the first part of the process there, I think. Just figuring out where the CMake executable is at based on the whatever paths are the standard for saving the CMake executable. So it creates this other class, which is the paths class, to manage a bunch of paths. And then I think here is the thing that is going to search for. So they use this, the thing that is the final thing that is the relative path that usually CMake is stored at. And then they search for default paths based on the system here. The process is another library, I think, that gets the environment you have. So process.env is whatever operational system you're using. It's going to access logic from that. And this gets some Visual Studio. And I think that this is the function that calls. So these are some normal paths where CMake is stored inside of Visual Studio application. Then you get the VS installations they get based on the VSware executable that they save somewhere here. Or on the RAS folder there that I showed. Right here, VSware. So they use this VSware to call this command here. As far as I understand, based on ChatGPT and Perplexity, so they get the path based on this gets whatever the executable is at, I think. Yeah, based on the current system, they get the VSware executable. So just getting the VSware, executing the VSware, I think. And this command is just gonna convert the output into UTF-8 format. So after you execute the VSware, you're gonna get some output and then it converts everything to UTF-8. So you can get here the path to the Visual Studio installations based on the executable here. So just programmatically executing these commands on the command line. This calls the command line. Then you pass these arguments, which is this stuff here, which calls VSware, the VSware executable. Then based on that, it loops that. Then it's gonna put those paths on this array here, and it's gonna return this array to the other thing there. To this thing, then it loops over these paths and puts this final thing here. So it's pretty much just finding the absolute path to the CMake executable file. And then it's gonna put that path there, it's gonna cache somewhere. I'm gonna go back to the beginning there. This is the thing that I don't like about this, like it feels very confusing. But I'm not really sure if it's because maybe it has to be that way, but it's something that I experience very often. And I think it's just the nature, it's like something fundamental, it's just the nature of how everything works, like on the bigger picture. But a lot of the times I feel like the things are more complicated than they should be, probably. But I'm not really sure if that's the case or not. And I think that this is one of the main reasons why it can get very frustrating. And that's the thing that I talked about. Like I have to be real. Because I want people to think that I think it's very normal for everyone to get very frustrating, and it's just human nature. Because when you face these problems, the first thing that you want to do is just complain or get very angry about it, because that's just your subconscious mind trying to make you rationalize uh, your comfort zone and your lack of action. And the way that it does that is by creating the story that you project outside of yourself, the responsibility for whatever you have to do. So you're just gonna put on everything else so that you don't have, so you can justify to yourself why you are not doing the things you know you should be doing. So I think that's the reason why it's a great thing to train yourself to, and that's why awareness is very important. I think it's probably the most important thing you can exercise. And the awareness, in the way that I think about it, is just observing the connection between past and future that you have with yourself. Because past and future are simultaneously created through the presence, because your frequency of awareness is going to determine the relative nature of past and future. So the connection between them creates your environment, and that's a consequence of your awareness. So the more you observe the thought patterns that come up whenever something happens, then it allows you to change the direction you're going. So, but it's very hard to do, because then you have to expend a bunch of energy and get out of your comfort zone to grow from these things that happen. And I think that's the reason why a lot of people don't do this, because it's very hard. Because if you allow yourself to not do this, then you can continue on the cycle that you are, and that's a lot more comfortable, and you don't have to spend a bunch of energy. Because if you put awareness on that, then you know you have to change, and then you have to spend a bunch of energy and take risk trying to deal with the situation. So I think that this is the reason why it's a very common pattern where everyone complains about everything, including myself. And like, you face the unknown, and then you're gonna, like, these things are gonna come up, and then you're gonna project outside of yourself, and then you're gonna complain. But then the way to solve that, or to become better at that, is by reframing on your mind, by being bringing awareness to why you're doing these things, and also through understanding that there's always two sides to the coin. So whenever problem you have, the only reason why you have the problem in the first place is because you have the privilege to have the problem. Because you're always gonna have problems no matter the level you're at, because it's always about the journey, not the destination. Because life has infinite potential, so that it means that you're never gonna get anywhere. So it doesn't matter how up or down you are, because it's always relative, and there's always infinite potential. So whatever problems you have at the moment is just gonna be a consequence of whatever problems existed on the past. So the only reason why you're able to have these problems is because someone else created this stuff and allow you to have it. So and by understanding that, by bringing awareness to that, it allows you to be more proactive and then start expanding, because you create an anti-fragile mindset. Because now every problem you face, you are grateful for it. And I think that's why gratitude is very important. Because then gratitude is going to put you in a position of power, because you're going to focus on what you can control. And then it's going to put you in an expansion mindset, where every problem you face, you become better, because you're grateful for the problems you have. And that's the direction I think is better to always try to move towards. So this is the thing that creates the CMake driver function, gets the CMake executable. Then this starts I think this is the thing that I want to see. So based on this, the communication mode is going to create. So as far as I understand now, because I don't have any configurations on CMake on the workspace, this is going to try to get the configurations from CMake, but because I don't have any, I think the communication mode is just going to be the default case. So it's not going to be neither one of these. And the reason why you have this stuff is because you can have different, it's just like a web application, I think, where you have front end and back end. And yeah, you can either set up the debugger adapter through use a server or to use a file, I think. But I don't understand very well how it works yet, the difference between them. But I think this is related to the way that the debug adapter is gonna run. So in my case, I think it is not gonna have anything, so it's gonna go to the default situation here. So depending which one it is, gonna create a different driver. I think this, so this is the function that is gonna initialize the class, and then initialize here. It's kind of confusing to understand the. Obviously, based on the names, I can assume what each thing is, but to actually know, it's kind of confusing. I think this config is another class that they initialize there on the extension, which is going to manage the logic for the configurations. This is just going to create the class. And then this sets the kit, and I think the kit is the kit is another thing. It's probably gonna be somewhere here. Like, it's the same logic from the debug target. They register a command here, and the command is gonna have the function that has all the stuff that is gonna happen whenever you select a kit. But I don't remember which one it is very well. I remember going over some of the logic, but I think that there is some logic as well on this path that I'm going that has some stuff that is related to the kit, because they check to see if you initialize the kit, and if you didn't, then I think they force you to, or something like that. It might be on this. CMake presets, I think, is the JSON file that you can use with CMake that allows you to change some configurations or something like that. So the logic is similar to the CMake stuff there. It's just based on the Visual Studio, I think. Visual Studio or whatever other kits you're using. It's gonna find the paths, the standard paths that the other executables are usually at, and then based on whatever kit you selected, and then based on that, it's gonna return those paths. I think a vendor, the compiler, and I think it's pretty much just the vendor and compiler and the linker. But it seems like it's just getting the compiler from here. I'll be right back. So after it gets the driver, I think it didn't go over this stuff here. So now I'm not really sure because I think that this is probably the one that is selecting there. And I'm not really sure if it matters that much. So after initialize the function there, but based on the communication, I think that's the one that's creating there. And it's creating the legacy one. So I'm not really sure why it's not saying anything there at the beginning. Because I'm pretty sure that and this is the thing that the reason why I was trying to build the extension and is because I wanted to debug or to put the console logs there. Because if I'm able to put the console logs, then it becomes a lot easier to understand what's going on. Obviously, because then I can just console log this information to see what the thing is actually gonna be. But the reason why I wasn't able to do that is because of the node gap there. So I'm not really sure if I should focus on that. Because I think I know how to solve the node gap stuff. You just put some logic, and I can copy some logic from the CMake Tools extension by using that executable VSWare to find the version of Visual Studio that I have on the PC. But then the issue with that is that either I have to do a pull request on the node gap thing so that they change, or I have to. And this is gonna take time, obviously, and I'm not really sure. Look, I don't have experience doing pull requests, so. The other thing, which is probably the thing that I would do, is to just get the project locally instead of using the one from node modules. But then I would have to change the package.json from this project here, and probably like I assume that there would be other problems that would arise, and this is the kind of the issue. So then I would have to change the source code from node gap, do the project locally, and then connect the node gap with the project, and then there are probably other stuff that would come up. So this is kind of the thing that is annoying. So I'm not really sure if it's worth to put the time to do that. But I think it's not showing this message here when I debug there. So maybe it's not selecting the CMake legacy driver. So the thing that I was saying here is that this CMake cache from path. So this is gonna probably cache the. Yeah, actually, let me see. But I'm pretty sure that this is gonna be the path to the CMake executable. No, it's not gonna be the path to CMake executable. It's gonna be the path to the CMake tags file. Because what this function is gonna do is just gonna parse the CMake cache text file, which is the file that caches the configuration from CMake. So the way that I think that they're doing this is just by, in this function here, they parse the path to the CMake cache. So the path is the CMake cache tags file, CMake cache tags. And this file is this one, which is a file that is going to contain key value pairs for the configuration of the build you did. So this file here. So what they are doing is just parsing this file and caching all the information here from the build. And I think that they are using this to create a configuration there. So they use this function here. It's probably reading the file and then getting the key value pairs and storing based on this other class here. I guess this is the thing that I don't like that much about the way that they did everything. It's like it seems that there's like all this a bunch of different classes, and it gets very confusing to understand what is going on. But I'm not really sure if there's any way to make it. There probably is, to be honest, but I'm not sure if it's worth the time to. The main thing the reason why I'm doing this is just to understand more how, the main thing that I want to understand is exactly what is happening under the hood when VS Code uses the launch.json to launch the debugger, like what is going on. And also, like what I'm contemplating about doing is also opening the VS Code source code. And as far as I understand, the way that VS Code works is that they use a framework called Electron. And what Electron does, as far as I understand now, is I think what they're doing under the hood is just use the same thing that the browser uses is just an engine that is probably going to create the bitmap information to render stuff on the screen allowing you to use JavaScript, HTML, and CSS. So, which is probably what the browser does as well. So the browser creates the interface between JavaScript, HTML, and CSS, and probably some either C or C++, or maybe whatever other low-level language that creates that communicates with the operational system and then creates the information of the thing that is going to render on the screen. So the bitmap, which is just the colors of each bit on the screen. And what Electron does, I think, is the same thing that the browser does. So it allows you to develop desktop applications in the same way you would develop an application on the browser. Not in the exact same way, but on a similar way. And I think that's how VS Code works. So I was thinking about, I'm not really sure if it's worth it, but should try to look into the VS Code's source code, try to understand how they do it. But I assume probably what they're doing is just going over a bunch of standard paths that they have, and then they go over the launch.json path eventually. Then they parse the JSON file, get the configuration from launch.json, and then they probably call the same function that they call here on the extension. So they pass the configuration in the workspace folder, and then this one probably creates a debug adapter. And this is the other thing I'm probably going to show that now. But that's kind of the thing that is kind of confusing, because how would the debug adapter know? Because it's gonna depend, I think, it has to depend for each language you're gonna use. And probably this is the reason why it works when you're using the CMake Tools extension and it doesn't work when you try to do it directly with launch.json. But like this is the thing, is because there isn't any logic here related to how GDB is gonna, like the logic is encoded in the configuration. So the default debug adapter should be able to handle, I think. So probably the thing that is not working is just the way that the compilation process changes the executable you pass here, just the target. Is the way that they build the targets, I think. The target is just another name for the final executable we have. So probably the default debug adapter from VS Code works, and that's probably what they're doing here. But the thing that I was going to explain from how they do it, I have to find now. There is some class here. I think I have the documentation open on how they create this configuration programmatically. This one here. And this one doesn't work if you try it. This is something that I'm not really sure why they did it like this, but you know, whatever. But if we try to run this configuration directly from here, it doesn't work. Okay, it shows you this message here. But the way that they do that is by calling some VS Code function there. I think it's, yes, register debug adapter. Yeah, so on this part here, so this is inside of the initialization of the extension class. They call this function, and this is the function that is going to register that thing there. It's going to make that thing show up on the debugger. Actually, it might be these ones here. Yeah. Oh, I think this creates the adapter, and then these ones put the configuration there. So you create a namespace for what the debugging thing is going to be related to, what language it is, and this is the function that is going to create the factory, I think. But maybe this is related to the way that the debugger works there on the debug target logic. Interesting. I don't know if this is related to the debug target or not. That's the thing. Yeah, but what I do know based on the stuff that shows up there is that these ones do create the debug configuration. So I think this one is the one that is gonna put the name there because like it's kind of obvious. So this is the thing that puts the configuration there, makes it show up here. It was based on this function here, which is the standard name that VS Code uses for this, I think. And this is the one that is gonna resolve the configuration you put here. So like it allows you to put the logic of what's gonna happen when based on this CMake pattern here. So because they put, I think that's how it works. Because they put CMake here when they are registering, whenever there's a configuration that has the CMake language on the name, then it's gonna run these functions here, as far as I understand. So when you try to run the other thing, it's gonna call this function here when you try to run this configuration here. So it shows up this message here, which is this message here. So I think that if you want to run with this, you have to set up a script on the debug configuration, or yeah, this. But this is the thing that I don't understand why they did it like this. So and I'm not really sure if this is related to the other stuff there. Like if this one is related to the factory is related to the debug target function. So maybe it is actually, now that I think about it. Maybe that's the difference actually. I think that's probably the thing. So I think it would make sense that this function here, so this is creating the logic of the bridge between the debugger and the GDB executable. I think that's probably what's going on. So the reason why it works when, so probably this is the configuration that matters. The reason why it works when you try to debug with the extension, and yeah, I think that's what's going on. So when you try to debug with the extension, it uses this debug adapter here, this one. But when you try to debug directly with launch.json, you don't use anything. So, and probably this thing here has the logic on how to. So the main question that I'm trying to solve is how are they? What is the difference between the way that they are building everything in the way that the final executable is gonna be? Like, are they building the thing in such a way that the final executable is gonna have the symbols on the executable itself, or are they building the configuration in a way that is gonna allow GDB to find the symbol files, the .pdb files, based on the way that they build the configuration? I think it's more likely that's the second thing is what's going on. So based on the way that they build the configuration here, somehow then GDB is gonna know about the symbols, maybe. Yeah, but I think now I realize that's probably what's going on here. Is that they're registering this debug factor, the debug adapter. And then when they call that function, it's using the debug adapter that they register here to build everything on top of the configuration that they have there. Or maybe this one is only called when you try to use the configuration that they put there, but it's not the one called when you run the debug. Yeah, I think that's probably what's going on. So this is probably not that relevant. I think the other one is the thing that gets the configuration. This one just gets whatever CMake project you're running. And I think this one's gonna be similar. So what is the name here? Oh, darn it. No. I think the name is probably the name of the file. Or maybe some cache name of the project. So I think this one is running the register. And this is the name. So it's probably some. There has to be. I need to remember what this exactly how this works. It's something from VS Code. So when, yeah, because the argument there is VS Code is gonna call that function, is gonna pass the argument. So registering a string is probably gonna work as a map. So whenever some UI interaction triggers that thing, it calls the callback function, and then VS Code passes a standard thing to that thing, which is gonna be that node there. Register is a command that can be evoked via keyboard shortcut. Registering command, blah blah blah. Unique identifier for the commands, a command handler function. And then you don't explain what's going to be passed through the function. So I probably have to assume what it is. But I don't think it's probably not related to the configuration itself, just related to some logic that they have to organize what thing they're gonna run the thing through. So let's see. But I think the name is just a cache that they use to, so it's just caching what executables are gonna be the targets for that specific project. I don't think the name is related to the compilation thing itself. So it just caches the thing the first time, I think. And this config data here, I think it comes from the configuration thing. So when you're setting everything up and creating these classes, it's gonna call a create function from this config class. And this is gonna call some VS Code function that gets the configuration for the CMake, which is the thing that is explained in the beginning there. It's gonna look for the user or workspace configurations that have a CMake keyword. And if you do have the CMake configuration, it's gonna get that, and that's gonna be the config data. But since I don't have anything, I think it's not gonna be anything. So this is probably gonna be false. But probably the first time this is gonna be true, so it's gonna run this stuff here, which builds the thing first. But the state is another class they have. Maybe name is the name of the file, I think. So probably the target node is the node that represents the file information. This target node here. Oh, it's just the project name. I don't understand very well. It's gonna be folder name, launch target name. So it seems like it is not related to. It's just a name that they choose. So it's the folder name and then launch target name. So it's just something related to the. So this returns no, I think, because there isn't anything the first time that it runs. It's probably gonna set our cache here. So this calls the same function that they have there on the debug adapter thing. I already lost where I was there. SS here. This is probably gonna be false. So it returns this thing. I think this is gonna be false probably. Well, this seems to be the main function that they call, just that the configuration for the first time, I think. So this is the one probably. And then this is probably gonna cache all the other information for the other times. So it has to be this one. I think this is like. So this callback is gonna be the other function. It was weird. How is this possible? Oh no, it's there. I thought that it was just, yeah. I thought this is the function definition here. I think soon I'm gonna take a break, I think. To meditate or something like that. I'm already getting tired. I'm not sure if it's worth it to do this as well. And maybe I should go back to just doing the, like, continue to, it's a massive tangent. And the main reason why I'm doing this is because I thought that it might be the case. I was trying to debug with Visual Studio, and Visual Studio debugger works fine, but it seems like it changes the project, the Rayleigh project that I was trying to study to see how to render text. They have a SDF text example, and when you run the example with the debugger, it changes the way that the project shows. But I think that's just a problem with Rayleigh. I'm not really even sure if it's a problem or not, but I think that they have some configurations there that change whenever you have a debug version running, and that makes the text change. So I thought that initially I thought the issue was because of Visual Studio Debugger, but and that's the reason why I was trying to debug with Visual Studio Code. But now I realize that it is pretty much the same. So if you try to debug with Visual Studio Code, you get into the same problem. So, but then it got me into this tangent that's trying to figure out. I'm not sure if it's worth it or not. Because what I have to do here, and this is the thing that is annoying, is it's annoying because you have to keep track of all the arguments and how they're going to change based on the execution of the whole thing. Because what I have to figure out is the final configuration that they are building. What are the paths that they are passing to the thing? And then once I have, so I have to manually build everything, and I can't use console logs because of the whole node keep thing. But if I'm able to manually get everything, then I have to build the launch.json based on all this configuration, but I'm not really sure if it's worth it. And it's not hard, but it's very annoying because then, like, I was writing down here Skyly draw. Maybe I should do that now. Because I have to follow the execution each time, then keep track of the variables that are being passed to the things here. To see what each thing is gonna be, and then it gets very confusing. And that's because after you go through a bunch of things here, that's the point that I'm getting now. Like, I'm here, but I already forgot how I got here in the first place, so I have to go back and follow the execution again to remember. But I think I'm following all this stuff to try to figure out what is the, like, in the beginning there, how are they building the targets? I assume this is gonna be false the first time. I already went through this. This is the thing where I got confused. That seems there isn't, like, I have to go back and see how what thing they're gonna pass here. I assume there isn't anything. I was probably gonna call this thing, but this is the other function there. And then it's just gonna pass other things. It's not this function, it's the other one. I think it's this one. And this is just gonna pass the normal thing here, then it's gonna call this. So other arguments. I'll be right back. Now, this is probably what's building the CMake cache or CMake flags. So here, this is gonna be launch, and the other one's gonna be normal. So this function is called both on the debug target and on the other when it's created the adapter factory. I think this is something I missed the first time that I was looking into this. But now I'm thinking that it's probably related. So the debug adapter that they create there, the pipe name is related to this thing here because of some configuration there. So the first thing is it configures the driver, which is the CMake. So the CMake driver is the class related to all the stuff that CMake is gonna do. So I think that this configuration sets up the commands on the CMake part. I'm still struggling to understand. The thing is, I think just by studying this extension, I'm not gonna be able to understand what exactly is going on VS Code when they run the debugger. It's something that is not clear to me. Like based on some of the stuff I've seen, some Stack Overflow answers and some articles, I don't have a lot of clarity if CMake does a compilation or not. I think it makes sense that it does, but I've seen some articles and some responses saying that it doesn't. The CMake just builds the makefile. So I think the reason why they were saying that on the responses is that it's because it depends on the kind of generator you use, I think. So the first time you run CMake, you select what kind of generator you're gonna use. And depending which kind of generator you're gonna use, it's gonna build whatever files are necessary to compile the project on whatever folder you put there. Usually it's gonna be on the build folder. So, but I think on the second time you run CMake, you should call the compiler. Based on the files that you have, they are gonna build the command line instruction that you're gonna send to compile all the files and link them based on the configuration you set in the previous command. So I think that's what's going on. So CMake should be compiling the project as well, and also because of the flags there. So you should be calling the compiler and passing these flags here based on these things here, because these are environment variables that CMake has that allow you to determine the flags that are going to be passed to the compiler to create the final executable. So I think that CMake is creating the final executable, and it should be creating the executable in the debug format because of this, and also creating the symbols because of the flags that I'm passing here. So like I don't see how the flags would be the main difference between these two different versions of the debugger, the version through the extension and the version through the launch.json. But one of the differences could be that the way that the flags that they're sending when they call CMake, that could be. But based on the output there, it seems like there isn't too much difference. I think this is the second command that you use on CMake to compile everything. You're just passing config debug, and maybe it could be this target here. So I guess I can put this, I can try this now. Let's put... But I don't think that's the problem. It's probably something else. And this J is just a... It might be that they're using a different compiler though. Or a different... Yeah, but I don't see how that would be the case. Because yeah, it can't be that actually, because they're using the CMake tags, the CMake cache file. So they have to be using the same compiler that I'm using, because they're getting the configuration from the cache. So this J, as far as I understand, it just selects how many parallel processes you're gonna run based on it's a flag for make, I think. But probably Visual Studio allows you to use this as well. But if this was the main difference, then it should work whenever it passes like this, because you should be doing the same thing that they are doing here. So I don't think that's gonna solve there. I think the main difference, I think, should be on the launch.json. But I don't understand, because I am passing the PDB files here. So what else could be like the difference? I don't understand. Yeah, that's the thing. Just gonna run the thing without going through the breakpoints. So I think the main difference has to be on the adapter, probably. Yeah, is the logic. And this is not gonna allow me to see there what this is doing. So this should be just, it returns this configuration from this file that I can't see what it is. Because it's this function here. That it seems like this is the main thing that returns there. And this is just for telemetry. I do think that the output there that is showing is related to the tasks.json somehow. But it was showing this the same output as well. I think the main difference is that before it was showing the other stuff that runs before this stuff here. But now it's just showing this thing. So I'm not really sure if it's related to the tasks.json. Oh, I think these environment variables come from this make cache. Yeah, because of the class there. Yeah, that's the thing. If I... Oh, this is from the legacy driver, I think. Oh, but this is the thing. I'm not gonna be able to know which one is using. I guess I can look into each one. Because there's the legacy driver, the server, and the other one. So I guess the function is from here. I think this is probably, as the name says, the path to be, to the folder where the binary is gonna be. It's probably the build folder. And so this is building the first command that runs there. I'm pretty sure that it is using Visual Studio. And the generator name should be Visual Studio. Let me see something. I don't think this is gonna change anything though. I'm just curious to see if it's gonna change the output here. Oh, maybe if I... No. I was gonna say if I delete the cache, but I don't think that's gonna change anything. So this is probably the thing that executes the commands, the first command that runs there, the CMake one. And so it's the build process. So this would be equivalent to tasks.json, I think. It's just running CMake and then it's building the args based on, and it's just gonna execute this command here. So the binary dir is this path here, which is the build folder, I think. And then the arguments are the flags that it builds there. So I think the target is, so this is one thing that I curious about. It's probably gonna be this T here. So the generator toolset is all built. No, maybe that's not. Or maybe this is the command that runs before this one. I don't understand why it's not showing now, but it was showing before. And then it's just gonna return the whatever is the result of executing this. So what the proxy does is just create a bridge between the object here and this thing here. So whenever you call a method on P, it's just gonna call one of these functions here. It's gonna perform some operation on this one. And so I think that's it's gonna return the results. This result is gonna be whatever is the result of calling that thing on the command line. Yeah, the result is the thing. Result time. So maybe when the command was successful, it returns a 0. Yeah, I think that should be the case. Because if it doesn't, then it throws this error. I don't think this matters for what I'm trying to do. So I think that all of this just executes that command there. The generator, the thing. But I think that's probably not the one that is showing here. Yeah, this one I remember seeing that the J somewhere. So I think it comes after this one. And this only runs if you don't have the cache, I think. If you don't have the build. So obviously I can try that there. Just delete the cache and see what's gonna happen. So the reason why, the reason why I think is not selecting this one is because it's not showing this message, but I don't understand how it's not selecting this one if I don't have a CMake configuration. Or maybe it is showing this. Because this doesn't stop the thing. It's just a warning message. So maybe it is selecting the legacy one. I think all of that stuff comes from this function. I was looking into this one. And this is gonna come from the node there. So it has to be putting this, it has to be creating this when it creates the instance. So on the start, in this start CMake driver thing. On this one, whatever calls that. No, target name. Oh, so it's gonna be this one probably. I think that's what's happening. Alright, so it creates the target name here. And it's based on this active build and the folder name. So it doesn't have something to do with the file that is being compiled or compilation process. More an internal thing from the extension to keep track of the targets. But I think it uses this one, which is all build. So because you don't set any target, it's gonna be this one, the target there that it gets there. And that's why it shows all build here. So this command it isn't the command that runs there. I think that the logic that we're seeing there is just the stuff that is gonna happen if you don't have the CMake cache file. So it's gonna build the thing first if you haven't built the thing. I think. So I think I'm just gonna test this now. Or either you're just gonna do that or throw an error warning message or whatever. There's something that I changed here, that it changed the way that it was executing. It is executing this, because I remember the output was different the last times, but I'm not really sure what exactly. A launch target with name undefined. So maybe it is the I think it shouldn't be. What is the order that's against this? So it creates the driver. When it creates the driver, it's gonna create the build, and then it creates this thing. And so it does this after it has the thing already. This is gonna be on this one. So the name's gonna be all build. And this comes from the configuration. So I think if I create a CMake configuration and I put this build before I run equals to true, then it's gonna build the thing before. And that's when it does this, but I'm confused about the, let's say, chosen. So I'm gonna assume that this is all build. So this is gonna be all build. But like the stuff that I was seeing is from this thing. That's the confusing thing. Yeah, it's from this stuff here. That should be this one. Cache flags. This one is the C one. This is the function that I was seeing. Maybe I just confused the functions there. I think I confused which ones. I looked into this one and I thought it was part of the flow there, but it isn't. This is the one that I was looking at. So I think I just confused the two things there. So when it's running, this is not gonna build anything. I think that is gonna execute. I don't remember really well. It has to be, because there at some point there, I remember that it has the execute command. I don't remember where. Maybe it's after this. I think this one is gonna be the CMake legacy driver thing. Yeah, so this is the one that thing. So maybe this it just returns no, or it just returns undefined. That's probably what's going on. Because not running this stuff. But it has to be. Yeah, here it has to be executing. Oh, that's weird. Because I don't think that the command, the stuff that is showing here is related to, is the same. It can't be, because it's obviously different flags there. But it seems that based on the execution there, you should be running this thing here. So I don't. This is the thing that I'm kind of. Maybe it is running, but it's just it's not showing for some reason. And so the first command you run is gonna build the cache. It's just gonna build the stuff. So by default, if you're using Windows, you don't have to put the /g flag, which is the generator flag, this one. And if you want to use another generator, then you can just specify with the G flag, and it creates different files. It's gonna allow you to use different compilers to create the executable. Maybe I should try to do that now as well. So this creates the CMake cache tags file, so it should work now again. Yeah. But the weird thing is that it's not showing the first command there, so I'm not really sure what's going on. So obviously, but even if this doesn't, because it should be running anyway, unless this is true, and then this is. Yeah, I guess this is the only thing that makes sense. Like this is gonna be true, and then it doesn't run this. That's probably what's going on. So I think this is gonna be all built, and this gets parses the cache file, gets the thing, and then this builds the configuration. So this is all built. This is gonna be key value pairs. It's gonna be a class that holds the key value pairs for the CMake cache file. And the thing is this workspace folder here. So this is the stuff that I have to figure out. Because like this is the thing is that this should be undefined because I don't have config there. There's another class that I pass to this. And this class is gonna have another class that they pass. So when you create the kit, it creates these classes. And then the config is from this thing here, which is this is the workspace folder based on the VS Code stuff. And the config that they have there comes from this class, but the problem is that this one is gonna call this function which gets the configurations from CMake. So, but I don't have any configurations for CMake on the user settings or the workspace or like the other places. So I don't understand, like this should be returning an empty object, I think, because I don't have anything here. So this is kind of the thing. If it is an empty object, then the other stuff there should be undefined. This path here, because this is an empty object, so it doesn't have the debug config thing. So I guess it should be undefined, or it should be an empty object. And this one is gonna call based on paths, gonna call other functions that are gonna set up the configuration. I remember, but the challenge is like figuring out what is the. Maybe this is not necessary. So this is another thing that I was gonna do. Just search for this on the cache. So I do have this. It's gonna be the linker that uses. So it is probably creating this one because it ends with link x, I think. Link x. So it creates this configuration here probably. Oh, so you don't need to have them on the You're just gonna get it from here. And so this is the... So I assume what is going on is that this configuration that is going to return here is going to be the same thing that you would do on the launch.json file. This is weird as well. Because if the target is all built, then it doesn't make sense, sure. Maybe I'm getting this wrong. Just confusing as fuck, man, not gonna lie. Like, I don't like the way that they did this stuff. So it should be all built here. And I assume that it's gonna be all built because the other stuff doesn't pass. So it's just returning all build. But if it is returning all build, then it doesn't make sense. That's... Oh no, the target is the first argument, I think. So I'm confusing the two. Yeah, it's the cache. So target on the other one's cache, not the target executable. No, it is this thing here. So the other one shouldn't be the... this shouldn't be this string. Should be... Oh no, it's because chosen is executable. It's not executable, it's this class here. So this gets created in the beginning when it's creating the thing. So, let me think. So I have to go back to this. So when it initializes this, it creates the thing there. Which is gonna be on the legacy. So I remember I saw that, but I don't remember exactly where. I think it's probably here. It was... Maybe it's here. Basic needs. Trying to remember what is going to be the executable. I think it is created when you create the CMake driver class. It has to be. So it's probably on this one. Oh, so this is the one that creates the commands. The other command that is going to run. So the command that is showing there is created there. This command that is showing here is created on this function here. I remember seeing this somewhere. And DJ is the parallel jobs. Yeah, so it creates the command here. Target's gonna be a target. So maybe through here. Oh. So initially I thought that the target's gonna be all built there, and I don't remember now where I've seen that. But it seems that it is gonna be the class that has the all builds, and I have to know the other thing, which is the path. So let me go back again. Yeah, so the path should be this. The path should be the CMake cache file. Let me go back from the beginning. Oh, maybe it was here actually that I saw, I think. Yeah, I think it was here. And this is the function against the... Hmm. It has to be here and here. Oh no, it's here. That's where they start. Default build target. So it should be this one. Yeah, but this is that's the reason why I thought it is a string, is because it just returns this. So I don't understand. It doesn't make sense. Because if this is a string, target name. Or maybe I'm confusing the two things there. I think I'm just confusing the names. So it's probably not here. Executable targets. Comes from executable targets here. It's not this file. So maybe it doesn't initialize here. There should be an empty thing there. And if it is empty, then the other stuff doesn't make sense. I think I'm gonna continue from that point and assume that it's empty. I think I confused this thing with the executable target thing. It's not the same. But then it doesn't make any sense. Because this has to be so yeah, but if it isn't found, it's gonna return no here. So the only thing that makes sense is that it returns no because it doesn't have anything in the beginning. Yeah, I think that's so assuming yeah, but then if this returns no, it just throws an error. So it should be here. That's the only thing that makes sense. I think the target should be the path to the executable. But I wanna see... I wanna understand how they do that. And this is what I mean when I think that there should be a way to make this like less confusing. Here is passing the sim. I don't think it's the CMake. I don't think it's the path to the CMake. It's the path to the whatever executable we have there on the build folder. And the only thing that makes sense, it should be initializing here, because and then it's gonna depend on whatever thing you are doing. But it seems that when you initialize the other stuff, it doesn't have anything related to the executable target, unless it's after that. But here it seems like it's not the same thing, so it's just a target name. It's gonna be a property. It doesn't make sense. Yeah, I don't like. It should be an empty thing there. It doesn't make any sense. Unless it's here somewhere. So I assume that this cache path is gonna be the path should the CMake cache thing. So it should be calling this, I think. Yeah. But this is not related to the other stuff, so it doesn't make sense. Like it seems like there isn't anything that is related to the executable thing. So this is the first function that it calls. That is and it should be no. Oh, maybe yeah. This has to be no, and then it's not gonna call this. So I think that this is no. I was just looking at the wrong way. But if this is no, then it doesn't make sense here. Yeah, it can't be no actually. So obviously it makes sense to assume that it's just gonna be the target name is gonna be the name of the executable or the name of the file without the extension executable, and then the path is gonna be the path to the where the executable is at. But so maybe this is one thing that is wrong on the. But if it is wrong on the launch.json, then why is it running? That's the question. Because here I'm putting the workspace folder, and that's not the path to the executable. So the path to the executable will be this debug. I think it just changes when where you're running the command from, I think. So here is an environment variable that the CMake Tools extension creates. Which is just gonna get the path to the executable, which I think is the same as putting this path here. But if you do it like this, then I'm not really sure. Because this should be running from the whatever path you have on the terminal, I think. So if I put the path, this path here, then it's gonna mess up this one here, I think. And it seems like that's how they're doing here. Unless this is the path to the build folder, but I don't think that that's the case. No, because the program, so it's the same path on both of them, I think. Maybe if I change, should use this thing here. But the thing is that I got this from the example, so I don't see how this would be wrong. The other way. Yeah, that should be the correct. Let me try this one. It's probably gonna be the same error. Oh, it works. Interesting. Interesting. So it works, but now it has the same mistake that the other one has. Interesting. So probably this mistake happens because of some path. I think it's the path to the font. That's the problem. So I think I understand now what's going on. So because they use the wrong path there on here, then the program it doesn't find the font on the correct path. That's what's happening. Because this example here, they initialize the font based on the relative path. So I think that's what's going on. So because this doesn't find the font, and that's the reason why I think, now I remember, it's because I was going over the debug with the Visual Studio, and then I saw that this was a null path. And the program still runs, but then it runs with the wrong font. And that's the reason why I wanted to run on Visual Studio Code. I think I remember now. So I think now I understand what's going on. So they set up the path on the extension the wrong way here. Maybe it's not the wrong way, but because they set up the, but yeah, it has to be the wrong way, I think. But this is the thing that is kind of tricky because it's gonna depend on the way you build things. Yeah, so it's very challenging. But I assume that it is probably the wrong path because like you're always gonna assume the relative path from the build folder when you're accessing resource files, I think. So this should be, so it shouldn't be target path. It should be like it should be it should be the binary dir path, I think here, or on the on this one. Huh. I think that's a mistake. If they put but I don't remember. Yeah, I don't remember if the binary dir like from what thing it is, from which class it is, and that's part of the problem I have with the way that they build this stuff. It's very confusing. There's a bunch of classes and like the feeling that I get is that it shouldn't be like this confusing. You should be like simpler to build this stuff. But it might be this way because of the, and this is I think another problem. This is the reason why I was saying that is more of a bigger picture kind of thing, is because whenever you're building these tools, you have to imagine all the possible different ways that people are gonna build, and because of that, then it ends up becoming very complex because you have to deal with a bunch of different variables. So I'm not really sure if it would be possible to put, but I think if I put binary dir here, which is the path to the build folder, then it has to be the case because here it's gonna solve the issue there that is getting null from the relative path here, which solves the way that the thing is there. So if I put just the workspace folder here, but this is not the build folder as well. So maybe it is a problem with Raylib, not the debugging thing. Or I should, yeah, but I got this from the example though, so. Or if I pass build here, but then.
The mystery of life isn't a problem to solve, but a reality to experience.
Because the thing is, I have this file on both the, yeah, so this works. Like I have the resources on both the main thing and the build folder. So I think that the correct way should be to put the path to the build folder, not the target. So I think it's a problem with the CMake Tools. Is an error from the way that they do this. This should be the build folder, not the path to the target. And I think the reason, like, it has to be an error with the extension because CMake is always going to build the final executable either on the /debug and then the name of the executable or /release. So they should assume that the main path of the project is going to be 2 levels up, the path of the executable. So this shouldn't be the path to the target, should be the path to the build folder. Yeah, and I think so. The way that they are doing it here is probably the same way that the Visual Studio is doing. But now I'm not really sure if it is supposed to be this way, and you should develop the application thinking about the path from the target. Is either an error with this thing or is an error with the way that Raylib did the example? Is either it has to be either one of them. So either this path should be 2 levels up, or the thing should be on the build folder. I think it's more likely that it's a problem with Raylib, to be honest. Oh, but it's, so maybe I'm just putting the path. Oh, it has to be built. Slash build. I think, not really sure. Because I'm assuming the workspace path. But maybe they did this example like this because like you don't know. No, but like it shouldn't be. Oh, so now it works. You don't know how the project is gonna be built, so the example can depend on the way that the path can depend on the way that the project is gonna be built. That's probably why they do it like this. Or maybe you should have the... But the thing that is weird is that I do have the resources here anyway. So it should be working if I put the path like this as well. Maybe if I... Because it's building from the workspace, which is the root of the project. So it should access the resources path. But I think that's the problem, is because the final executable is not on that path. That's the issue. Oh, it works. Also, it's probably a problem with the way that they did on the example there. Because I remember I copied exactly the way that they did it on Raylib. So I think it's a problem with Raylib. But maybe it works now as well. It doesn't work on the other one because it's a different path. Hmm. I'll be right back. I actually think that the problem is with CMake Tools in Visual Studio. Because I think it makes more sense to, for the person that is building the application, should think about the relative paths either from the build folder or the final folder that you're gonna put everything, or to put it from the root folder of the project. But the root folder of the project doesn't make a lot of sense as well, because I imagine that to distribute it, the thing, you're only gonna distribute the final build folder or whatever folder you're putting everything. So I think it should make more sense to build it from the final build folder, the relative path. But maybe it's because of the way that I'm doing the CMake list here, because now I realize as well that they build this out file here. So it could be just because of the way that I'm building the CMake list file. So the way that I'm copying, I think... Oh, I'm not copying, that's the thing. Oh, yeah, I forgot to copy. It's because I was doing that on the other project. I think this one I didn't do it. So the issue is probably that I forgot to put the... There's a command on this on CMake that allows you to put all the files. Maybe it's this. No, this is from the other one. I think it's file, and allows you to copy the resources from the folder you're building to the final folder. I think that's the issue. So I forgot to put the command to copy everything. So what's happening is that when I build with my commands, then it puts everything on the build folder, and because I put the resources here, then it finds the tags file. But when I build with the debugger, they create another folder, which is the out folder. They put on the out and the build, and then on this one it doesn't have the... It doesn't have the resources, so it doesn't find the fonts. Oh, so here is the command, so it is showing. So this is the first command there that I was looking at. So they pass this stuff here and they build based on that. And the generator is Visual Studio here, the flag. So this is the one that I was looking at that runs first on the CMake driver class there, on the config internal. And the other command that actually compiles is build after, when you get the target. So I think it's probably my mistake there, that I didn't copy the thing. This happens because you don't have the standard of where to put the final things. So it makes sense for them to not. Like, I think it's your responsibility as a developer to take this into account. Yeah, that's the issue there that I was getting, because there isn't a standard for where to build the final files. So it's probably my mistake. So yeah, the issue is because the CMake Tools builds the project in a different final folder than the way that you decide to do it. Then there's this difference on the relative paths from the two different ways, because the way that they build everything. So let me... so it only makes sense that the target path there that you get here is in relationship to whatever they are gonna build. So it's not the executable that I have here. So I think what I can test now is, because initially I thought that they were getting the path to this executable here that I have, but now I think it makes more sense that they're getting from the one that they built here. So so I was thinking about that they use the same one, but it's different ones. So they build. Oh, so now I think I understand. So whenever, because there, I remember seeing some logic there that whenever you change the CMake list file, it builds everything automatically. I think that's what's happening here. So the version of the project that they build is different than the version that I'm building. And initially I thought they are the same, but now I think that's different. So they build everything first based on whatever you change here, and then they cache all the information, and that's the reason why it's not showing there when you debug directly, because they are creating the first version based on the command that they build there on the CMake driver, when you create the CMake driver. And this probably happens when you run the kit first. So it isn't the logic that I was looking at here, because the logic that I was looking at is for the debug target, so it only happens when you click the button here. But it probably goes through the same functions, but it's just different paths. The path that they probably go through is whenever you create the kit first, then it sets everything up to run these commands here to build the project whenever there is a change on the CMake list file. And then they build on a different path that I was building, and they created another executable, which is this one. So now I think that it makes sense. So they're using a different generator. That's the difference. So because they're using the Ninja, I think. But now I'm not really sure, because the flag there is Visual Studio. So, but maybe it's Visual Studio with the Ninja thing. Or is because they're using, yeah, but I think this flag comes from the CMake list that I have there, because I remember putting this. Yeah, I think it comes from this thing here. So they sat here. But it might be because I have to, even though I'm putting on the CMake list file, I have to manually put this here whenever I build. But it's weird because they are using Visual Studio here, so I don't understand why he's building with Ninja. That's the thing. With this, it is the path to the build folder. I don't, I'm not 100% sure. Because I think this is the first command that runs, so is /s here to determine the source. So they are assuming the source is on the build folder here, which doesn't make a lot of sense. So maybe they are building the other project from this source here, using the generator Visual Studio. Why does it build on the alt folder? Yeah, they build first and then they call this stuff here to compile. So this is the main difference, I think. Now it's becoming more clear on my mind what is the difference. So initially I thought that they were building the same way that I was building. And that's the thing that was confusing. So that's why I didn't understand why when I use launch.json it doesn't work, but when I use thing it works at breakpoints. Because I thought that they were building the same final executable that I'm building when I put the commands manually there. But now it's pretty clear that it isn't the case. So, but I still don't understand why, like at what point, because there isn't any out path here. So this command seems like it's calling CMake, then it's passing this flag variables. These I remember from the CMake driver logic there that they're gonna look into the CMake the cache file. So I think what they're doing is they're getting the build from here. So they're parsing this file here, and they are getting the command line arguments that they're gonna use to build their version of the thing from the cache that you have on the build folder. I think that's what's going on. So this is the reason why they put this stuff here, because the CMake list that I have there, it has this argument, and this one puts the flag variable on the cache. Yeah, so it passes this. So they get this argument from there. Because I remember seeing some logic related to that. And this dash s here determines the source. That's how I was running as well. So the first time you're going to run CMake, you pass /s, and then you pass what path you want to build the stuff from. Here's the /s. In my case, I'm building from the root directory of the project. And then you pass /build to determine where the final files are going to be at. So they're passing. So they're passing the build folder as the source, but they're not passing any. That's the thing that is weird. So I guess when you don't put the build, it just passes to the outs. So when you don't put /build here, if I just put like this, the default is probably the out folder. I mean, that's the reason why it's building everything here. It's probably out and then build. Yeah, I think that's what's going on. So whenever you, I can obviously look into the documentation and see, but that's what's happening probably. Oh no, it's building everything here, so it isn't. What's happening? So why does it put everything on the out build here? I don't understand that. I'm gonna try to run the same command. I'm gonna try to run the same that they're using there. No, I don't think it should work. It's very confusing actually, because like, this should mean that he builds on the final build folder, so. Just this folder here, not this one. I guess let's delete this. So yeah, maybe. But then why does it fuck it up there? Oh, that's weird. Oh, so maybe I think the out folder comes from Visual Studio, not the. Yeah, because when I debug with Visual Studio is the thing. Oh, but it's still fucking it up here. Hmm. Yeah, so it is a problem with the path, I think. So the out folder, I think, comes from Visual Studio, not the CMake Tools. So I think it does make sense that what they're doing is just using the generator. They're building the same executable. So it is the correct what I was thinking about. So they are building the same executable. And it is weird that it works when they build. The breakpoints work when they build, and it doesn't work when I build. Maybe this is not from CMake Tools as well. Yeah, I think that's probably just from Visual Studio. No, I think it is from CMake Tools, but it's set up on the kits. So this logic is set up on the kits. Whenever there's a change on CMake list, it runs this, which rebuilds the project. But it just uses the generator that it gets from the cache. So you have to build first manually, and that determines what thing is going to use. And then it just rebuilds with the same configuration. I think that's what's going on every time you change. And then the main one that runs when you click on the debug is going to be that one that shows up later. So I do think that it is a problem with the way that they build the paths on the CMake tools. Because the final path that the executable is going to be is always going to be the relative path, which is the /debug/ the executable name. Regardless of which folder you choose to build, to put the final build on. So the path that they put there should be relative to that path. So I think that's a problem with the way that they build this one. So instead of target path, it should be two directories up, so that the directory that VS Code assumes is the root one is the one that contains all the other files. So it's the one relative from the final executable, which is on the debug/path. So I think that's the problem with the way that they build the thing. I'm still struggling to understand what is this thing here. Like, I don't understand how is it possible. So this path here is the one that is wrong. And I do think that now it makes sense. So this configuration is the same one that it's gonna have on the launch.json there. But now I have to understand like what the fuck is going on. Target path. Like why do the symbols work on extension but not when I use launch.json? The only thing that makes sense is the configuration, but or maybe it's the type. So I think you can either be the type or the see if it runs anything. I think this one is an object there. Yeah, here. There's gonna be GDB, it's gonna be this one. It's VP GDB. And GDB. Yeah, is both of those things are true. I think it's one, like, it's my mistake for not putting the file thing here. So that is true, but it's also true that the CMake Tools is wrong. So I think from the Visual Studio debugger point of view, like, if I put the file copy here, it should work on the Visual Studio, but it's still not gonna work on the CMake Tools because they put the wrong path there. Or maybe Visual Studio does the same way, but it wouldn't make sense. So if they both do the same way, then the problem is with Raylib, I think. Because you should assume that the relative path is gonna be from the final executable, which is gonna be on the either debug or release. Oh, it should be from Raylib, I think. I'm not really sure. It has to be either one of them, but probably Raylib. I think he's gonna get this one. Oh, maybe that's the reason. So yeah, I think I'm gonna test that. So probably is getting this. So I think I understand what's going on now. So the launch.json configuration I have is for GDB, but I'm using the MSVC to compile. That's the problem. That's the reason why it doesn't find. Because it's expecting for me to compile the thing with the /g thing to create the symbols. And that's why GDB can find the symbols, but I'm using MSVC to compile. That's the problem. So, and the thing that changes is the type. So what I should do is just remove the stuff that is not. Type name request. What the fuck? What is this? I'm gonna remove anything that it doesn't show there. So name type, type name request. So it's another. There we go. Nice. Figure out. Oh, this actually feels so good because I thought that I probably wouldn't be able to figure out because of the paths. In order to print the paths, I would have to build the project and then I'll have to solve the node git thing. But I wasn't I thought that it, and it isn't worth it to go through all the stress or all the work, because then like I'm losing time from the stuff that I actually want to do. But now I think that everything makes sense. So I think I understood everything. Nice. So the thing that I still I'm gonna think about more, which I'm still not 100% sure. Like I don't know 100% if it's only my problem, because I definitely think that I remember thinking about this as well, that I was gonna build the command, because on other projects that I'm building, I have this command here to copy the shader files into the final build folder. Like you put the file command and then CMake is gonna copy all the files that you put there. I think on this project here, the project that I'm building there, I have this command on CMake list, and I was gonna do the same, but then I thought that it's not. Yeah, I just wanted to solve other stuff, and so I ended up not putting there. I don't remember. I think it's on this one. Yeah, it's this command here. So this one, it just copies whatever you put here, all the files inside of this folder, into the destination, whatever destination you put, and this is the binary there, which is gonna be the final directory that you put all the files that you're gonna do. So like on my case, on this command here, if you're running to compile the project, if you're running this command, you're gonna put all the files on the build folder. So the CMake binary there is gonna be the build folder. So just copying all the files here. Usually it's gonna be the resources you use, which is gonna be either shaders, font files, models, stuff like that. So you put this on the CMake list file so that you have access, and then you can use the relative path from the build folder. But the thing is that I definitely do think that this is a problem that I don't have there, but I don't think if I put that, it's gonna solve the issue there. Because either way, the relative path here assumes that this is running from the build folder, I think. It's the final folder that has everything. But the path that they're using to debug is from the path of the executable. So like on the CMake Tools. Here, obviously, you can change. So I think from here, it should probably be working, I think. Because I'm putting the workspace folder, which is going to be the main folder, I think. In my case, you have the thing on two of them. But I should put, yeah, so it works. But I think the correct way to do it is to put you put on this thing here, whatever is the final build folder you have. So I think what they should do on the CMake Tools is put the target. So they should change from putting the target path to putting two things above here, because this is always going to be on debug, actually debug. Yeah. No, they should go to up because it's going to be on the debug. So is the build folder, whatever you put the final files, and then debug, and then the executable name. But they are putting on the executable name, so that makes it so the relative paths break. I think it's a problem with the CMake Tools. And it can also be the case that Waylib should put the path from thinking about from the executable, final executable. Yeah, but the thing is, what happens when you run directly? So this, but I guess it's gonna depend on what folder you're running the thing from, maybe. Yeah, I'm gonna. So if I do this, let's say. This is something that is kind of hard for me. I still don't know. I'm thinking about looking into this more later. But and it's kind of hard to find videos talking about this, but like because obviously I use other programs. So from the programs you normally use, the final executable is going to be on the root folder itself. It's not going to be on the debug thing here. So I think it's probably the common practice to build on the release thing, but then move the executable to the root of the project. So yeah. So I think that actually CMake Tools is correct, because you should always assume that the executable is going to be on the root of the project. I think it makes more sense. And then, but then this is kind of the issue, because yeah, but I guess no, it doesn't matter. Let me, oh, so yeah, it's not a problem, I think. But actually, it is, because I was gonna send you're gonna change the executable anyway, so it shouldn't be a problem. Like you should assume the relative path is gonna be from the final build folder. But then it is a problem, because if you want to debug, then it's gonna show stuff that is wrong, even though it is right, and that's gonna change the logic there. So yeah, I do think that it's probably CMake Tools issue. You have to put the relative path to the final thing. So it should be should be two directories above whatever the final executable is going to be, because the debug version is always going to be on the /debug thing. So I do think it's a problem with CMake Tools. But it's not a problem with really, because even though you're going to change, the relative path is always going to be the same, I think. But maybe not. Like if you assume the relative path should be on the build folder, then the final executable doesn't matter, because it's still on the build. So if I like move to here, then it works, I think. And that should be the case. I think that makes more sense. So it is a problem with CMake Tools. Because I don't think but it comes down to what is the norm to distribute the executable. Like if the norm is to distribute on the without changing the path, then is a problem with Rayleigh, because you should assume that the final executable is going to be on the debug thing, so you should go to or one directory up to get to the root of the final thing. Actually, it has to be. I'm gonna build with the other one. Yeah, so now is it no, it's weird. So now there's another problem. I'm not really sure what it is. Maybe some other path, something like that. So I think yeah, I've understood everything that I wanted to understand, and I'm gonna have to spend some time thinking upstream about this relative path thing. What is the correct way? And hopefully someone that watches this can comment, but I don't expect that. So and I think that I'm just gonna research this stuff later on. Once I have like a final application that I'm gonna distribute it, then I'm gonna spend a bunch of time researching what is the best. But intuitively, it makes more sense to me, and based on all the other applications that I use, that probably the correct way is to build with the the relative path in mind should be from the root of the project, I think, that you should put there. So this path from really makes sense. I think that's the thing that intuitively makes more sense. And then either way, it doesn't matter. When you're running the project, like it doesn't matter if you put the relative path assuming that the root is gonna be on the wherever the final build is, because if you're running from the command line, you're gonna run from the main folder anyway. So, or you're gonna run from the build folder, and then you're gonna have the assets there when you're running the project. And if you change the executable, it doesn't matter anyway, because then the executable is gonna assume it's just gonna be on the root path either way. So I think intuitively it makes more sense that for relative paths, you should assume that the root is the final build folder. And the problem is on the way that they build the CMake tools, because they're putting the relative path. They're putting this path here as the executable path, and it should be one above that, because the one above is gonna be whatever the final build is gonna be at. I think that makes more sense, because the debug build is always gonna be a standard path. Yeah, so pretty happy with this. I'm probably gonna move on from this now. This is the main thing that so probably what I'm gonna do now is just use the launch.json file. So, and the thing, it makes sense. So, like the reason why when I call GDB here, it doesn't find the symbols is because I'm compiling using the MSVC. And this is the thing that is kind of confusing. I don't like that much, to be honest, is because like on all the tutorials I've seen, and yeah, it seems like people just say that all the resources I've seen, they say that you should put this flag here when you're using MSVC, and then if you put this flag, it's just gonna generate the symbols. But the issue is, I think that it is true, but it is misleading, because like what this is doing, I think is making the compiler generate these PDB files here. But just because you generate these PDB files doesn't mean that GDB is going to understand that you generated them. And this is the problem. So, and I think that's only a problem in relationship to the debugger in VS Code, because like I said before, there is a command on the GDB documentation that they talk about. So after you initialize GDB, if you can't find the symbols here, then I think use file or something like that is the 16th chapter, I think, on the GDB documentation. And then you can manually tell GDB where the PDB files are. And if you do that, then I think the symbols start working. Or yeah, and then it allows you to put breakpoints. So I think it's a lot more clear now in my mind. Trying to find. This is the documentation. I think it's on this here. So, but the problem is that all these commands are just they work after you initialize GDB, I think. So there is a command here. Yeah, info symbol, I think is this one. Info address symbol. Oh, maybe it's somewhere else. I do remember seeing it, but I don't remember where it is. Yeah, but basically after you initial, I think it's this one. Oh, it's just info. Maybe sat. Oh, whatever. Some of these commands here. Maybe this. They allow you to specify to GDB where the PDB files are. But this command alone is not gonna allow GDB to, out of the gate, to read the symbols from the executable. So it doesn't build the symbols on the final executable itself. It just creates the PDB files. So that's why it's misleading. So if you want to use GDB as the debugger, then you have to compile using the makefiles generator. So the first time you run CMake, when they're running this, you have to put, I don't remember if it's before or after, but you specify Unix makefiles here. Maybe I should try this now. So you have to delete the cache. And then what this is going to do is it's going to generate a different kind of build that is going to use a makefile to compile. And then when you use the make file to compile, the final compilation is going to be for Unix systems. So, and then when you do that, then if you pass the G flag, then assume that GDB is gonna, like the final executable is gonna be ready for GDB. So if you build from MSBC, then you have to use this other type on the launch.json, because then probably what it's gonna do under the hood, I assume what's happening under the hood is that VS Code is gonna get a new another debug adapter based on the type here. So they probably have some logic that reads the launch.json file, and then they have some switch statement or some control flow that based on the type that you put here, it chooses a different debug adapter. And then when you're using the Visual Studio compiler to compile the thing, use a different debug adapter, and because you use a different debug adapter, the debug adapter has the logic that's gonna allow the debugger to find, or is gonna use a different debugger that's gonna find the PDB files and load the symbols for them, and that allows the debugger to put the breakpoints. So the issue that I had is that I was trying to use a debugger I was trying to use GDB, which only works when you compile using Unix things. And so here you can see that when you use the other generator, it creates this make file here, and then you have to run make, and then make is gonna compile the thing. So I think if you're doing like this, then it allows you. Then what you have to do is change the configuration, so you debug with the GDB, and you have to set this file /g here on the CMake list, because that's gonna create the symbols on the final executable. So either you use the Unix generator and you use make, and then you use the GDB configuration on the launch.json, or you use the MSVC, and then you use this different configuration here. So the type is the thing that matters. Nice. So yeah, I think I'm gonna stop here, and what I'm gonna do next. So I'm gonna think about this relative path more upstream, and what I'm gonna do next, regardless of the thing, is because this is not the main project that I want to do. It's just debugging this one to understand how to do the tags. So I'm probably just gonna I'm just gonna put whatever path works here with the debugger, and then I'm gonna step over this project with the debugger to figure out, which I already know to some extent. I think the problem I have with the other one, the reason why it's not working on the other project that I did to create the tags, is the position. So the main difference between the way that I'm doing and the way that they are doing is that I'm using a different camera to create a model view projection matrix multiplication that is going to get the final position of the tags coordinates, or the geo position for the tags coordinates. That is going to create the final tags on the screen. So because I'm doing that, and I think that's the case because I looked into the render doc, and actually the last time that I streamed about this, I realized that the reason why I was getting the wrong position is just because I changed the project there, and I put a different thing, and that fucked it up. But then I think I'm pretty sure I went back and I changed that again. So the reason why is because I changed this to have a different position, but then I wasn't updating this thing here. And also I figure out how they do it on Raylib. So on Raylib, they use indices to render the text, and they use this index data here. They create the index data on the beginning. That's the thing that is kind of confusing. So they use alloc or malloc, I think, and they on this function here, they just generate a massive array that is going to have the indices, which is going to be based on this formula here. And then, so they create the data for the index buffer in the beginning before they do everything else. It's just going to be the same each time because it's the indices for rendering a quad, which is just two different triangles. And that's the reason why on the rendering cycle they don't put explicitly they don't create the data explicitly, because the data was already built the moment that they initialize everything. So they just bind the buffer, and then the only thing that matters is the amount of draw calls that you're gonna have, because you bind the image already. And so the reason why the position was wrong is because I changed to this. So But I think if I change again, probably the thing that is wrong is the position, because I'm using a different matrix multiplication and the coordinate system is different. So I think that's the only thing makes sense. Should be wrong. Yeah, and I did like this, and it seems that this is not working as well because of the positions there. So it's building the triangles on the wrong places. And the main difference is the way that they build the vertices on the draw texture pro, I think. Yeah, here. Because I changed to build on like this, passing on the thing. And the main difference is the coordinates, I think, that they use. So they build X and Y based on the whatever the scale of the camera that they have and the projection that they have is going to generate. But probably the way that the other project is doing to generate the camera matrix and the projection, the scale of the coordinates is different. So because the scale is different, then it forces you to use a different scale when you're building the vertices here. So I think that's what's going on. And because of that, it doesn't matter if I move the camera, it's never going to show because the relative position is also moving, because the camera is just multiplying the position of the object. So that's why it never shows stacks there, regardless of where the camera is at, because the scales are off. So the absolute position of the in the world coordinates of the tags is always gonna be off the camera because of the scales. I think that's what's going on. The next time, what I'm gonna try to do is just step over with the debugger and then try to figure out if that's the case or not on this project until I figure out how to do the tags. If I don't figure out, I'm just gonna use all the stuff that they use and then incorporate on the other project as part of a class, just call the functions from Raylib and then copy the functions. But I'm pretty sure that I'm probably gonna figure out and change the position so that I can render the tags there. So not sure when I'm gonna do that, but probably really soon. And yeah,